And for the last chapter, chapter 12, design analysis on single factor experiment. And for the topic for this chapter are completely randomized single factor experiment. And for the subtopic for this topic are tensile strength. Tensile strength resistance to the lengthwise stress measured by the greatest load in weight per unit area, pulling in the direction of length what a given substance can bear without tearing apart. Let's have an example. A manufacturer of paper used for making groceries bags is interested in improving the tensile strength of the product. Product engineering thinks that tensile strength is a function of the hardwood concentration in the palm and that the range of hardwood concentration of practical interest is between 5 and 20%. A team of engineers responsible for the study decides to investigate four levels of hardwood concentration, which are 5%, 10%, and 15%, and lastly 20%. They decide to make up 6 test specimens of each concentration level. Using a pilot plan, all 24 specimens are tested on a laboratory. Ngayon, gumamit tayo ng table para mas ma-identify natin ang mga data na ating magagamit. At yung data magagamit sa pag-test itong apat na specimens na ito, which are this. At ang total ng bawat observation ng isang specimens are itong mga ito, 60, 94, 102, and 127. At ang average nila is 10, 15, 17, and 21.17. At pwede din itong data na ito, pwede din gawing black box para mas madaling maintindihan. Tulad ng ito. Ang tawag dito is sa loob, ito yung mga data. At ang tawag dito is quartile. Sa upper part nito is ang tinatawag is maximum quartile. At sa baba is minimum quartile. At pwede rin individual distribution at ito yung magiging itsura niya. At which are magkakaiba ang magiging variance nito. Yung sigma square, lahat yan is iba kapag. At ngayon, para masolve naman kailangan natin i-evaluate ito para makasigurado dito kung ano ang magkakaiba na data. At magagamit natin dito sa next subtopic, which are analysis of variance. Suppose we have a different levels of a single factor that we wish to compare. Sometimes each factor level is called a treatment, a very general term that can be traced to the early applications of experimental design. Methodology is the agricultural sciences. The response for each of the treatment is a random variable. At dahil dito sa table na to, mabubuo itong equation na ito, which mean plus tau plus error. At itong ang tinatawag na linear statistical model. At itong model na to, pwede rin isulat sa pamamagitan. Pwede rin isulat ng ganitong paraan, which mean of each value plus the error n. At malalaman natin ang expected value of the treatment sum of square. Which is the ANOVA partitions the total variable is the sample data into two component parts. The test of the hypothesis is based on a comparison of two independent estimates of the population variance. The total variable in the data is described by the total sum of square, which means ito ang magiging mabuong equation dahil dun sa mga naunang equation, which is sum of square t. And then summation lahat ng y. Itong mga to mula I to j. Tapos, dahil dito sa equation natin na ito, malalaman natin ang the partition of the total sum of square is given in the following definition. Ito, the sum of square identity is ito na tong lahat. Para sa symbolic or mas pinasimpleng equation para dito ay ito, which are sum of square t is equal to sum of square treatment plus sum of square error. Mabubuo naman natin ito the expected value of the treatment sum of square. Ito naman, itong equation na ito ay para dito sa error ng sum of square, which finally we concluded that e times sum of square e is equal to a times n minus 1 times the sigma square. And note that the mean square for error is MSE is equal to sum of square error over a times n minus 1. At dito ay mas mapapasimplihan natin ang ANOVA F test, which are F sub 0 is equal to summation of square treatment over a minus 1 over summation of error over a times n minus 1. At pwede rin itong isulat ng ganitong equation, ms treatment over mse. Tapos, mabubuo na dito ang sum of square computing formula for the ANOVA with equal sample size in each treatment are this. Ito na yung magiging final equation natin na magagamit para sa ANOVA. Para malaman na natin kung ano nga ba talaga ang data na magkakaiba para sa tensile strength. Ito naman para dun sa error. The error sum of square is obtained by subtraction as summation as sum of square e equal to sum of square t minus sum of square treatment. Para mas pasimplehan natin at malaman natin ang mga equation na mas madali, tignan natin itong table na ito. Ito yung mga actually kukunin natin, yung treatment, yung error, at yung total nito. At ito yung mga formula pwedeng natin magamit. At pwede natin pagbalik-balik ta rin at pagpasama-samahin. Depende na lang kung ano talaga yung hinahanap. Now, let's have an example to further understanding or apply these equations. This experiment is a completely randomized design. We can use the analysis of variance to test the hypothesis that different hardwood concentration do not affect the mean tensile strength of the paper. The hypotheses are design and analysis of a single factor experiment. Analysis of variance. Now, itong sabi ko nga, yung final equation natin is ito. Ngayon, ilalapat lang natin dito yung mga given na magagamit natin, which are ito. Tapos kapag kinumpute natin, magiging 512.96 siya. Tapos ang susunod naman natin hanapin ay yung treatment nito. So, pag nilapat ulit din natin, ang mga gagamitin natin, ang makuha is 382.79. Ngayon, pwede natin magamit yung table para mas madali. Or ito ang pwedeng gawin natin conclusion para mas makita natin kung tama ba ang pag-compute natin. At ang magiging p-value natin ay is equated by this. This is the last chapter for engineering data analysis. Thank you for listening.